Today we'll discuss Hadoop architecture. Okay. So first, Hadoop architecture. Hadoop architecture consists of 5 daemons. 5 daemons. One name node, and second one secondary name node. Secondary name node. Third, data node, and fourth, before 2.x Hadoop 2.x version. Before Hadoop 2.x version. Fourth one, job tracker. Fifth one, task tracker. From 2.x, from Hadoop 2.x. Fourth one, resource manager. And fifth one, node manager. So instead of job tracker and task tracker, in latest version, they replaced with resource manager and node manager. Okay. So these are 5 daemons. Do you have any idea what is daemon? What is daemon? Daemon is a process. Daemon is a process runs in background. Runs always in background. Daemon is a process which always runs in background. Which always runs in background. Simply, it is a program. It is a program. This program always runs in background. Okay, it is a Java program. It runs always in background. No, that is different. Yeah. It's a program. Java program. Yep. Daemon we achieve this roles of this name node, roles of secondary name node, roles of data node. Okay. So before going to start actual architecture, let's briefly discuss about Hadoop. The base of Hadoop is uh, GFS. GFS stands for Google File System, and MapReduce. Initial big data issue faced by Google. Google implemented GFS and MapReduce. Based on GFS, we have hdfs file system. So equal to MapReduce, So MapReduce they implemented in Python. So here MapReduce we implement in Java or Python. So base of our Hadoop is GFS and MapReduce from Google. Based on these two, duck cutting is the implementer of Hadoop. Duck cutting. Duck cutting is implementer of Hadoop. So vendor of Hadoop is Apache. Apache is a vendor of Hadoop. Hadoop is open source. Hadoop is open source. So what is open source? Any idea? So that is free. That is free. But what is open source? Ready updates. Okay. So anyone can contribute. Yes. Any other? So first one, open source means they give us complete source code. So they give us complete source code. Source code means set of programs. So whatever the programs that they designed for this Hadoop, they give complete source code. Okay. So based on this open source, there are some vendors. There are some vendors providing enterprise versions. Enterprise versions. So Cloudera is one vendor. So Cloudera.org. Cloudera is one owner of Cloudera, and Hortonworks. So owners also Hortonworks, and Big Insights. Big Insights is providing IBM. HD Insights. HD Insights is providing by Microsoft. Next, EMR Elastic MapReduce is providing by AWS Amazon. So there are some other vendors also, but these are popular different vendors which are implemented by Hadoop. So we have Apache open source Hadoop as well as third party vendors provided Hadoop. So these third party vendors implemented their versions based on this open source. Okay. So based on this Hadoop open source, these vendors provided enterprise versions. So we can find, so these are licensed. So Cloudera, Hortonworks, Big Insights, HD Insights, EMR, these are licensed versions. Okay. So complete Apache Hadoop is open source and free. Apache Hadoop is open source and free. Hadoop is implemented using Java. Hadoop is implemented using Java. So if you want to install Hadoop, compulsory first level on hardware, first we need to install any flavor of Linux operating system. Any flavor of Linux. On top of Linux, we need to install Java. So Java is mandatory. On top of Java, we run Hadoop. So to run Hadoop, compulsory we require Java. So we require Java means JVM. JVM stands for Java Virtual Machine. This is complete free sessions. Free sessions we are not recording and we are not providing any recordings. Yep. No, what I am saying here, so to run Hadoop we require Java, but Python we can write MapReduce on top of, once we install Hadoop, we can write Python MapReduce applications, or we can write a Java MapReduce applications, or you can write C MapReduce applications like that. Not necessary. So for running Hadoop we require Java. Okay. Only to run Hadoop we require Java. We can write Python MapReduce applications. Yep. Here we have different technologies. We have MapReduce frameworks like MR means MapReduce, Pig, Hive, Scoop, Flume, Uzi, HBase, etc. So these are different Hadoop frameworks. So MapReduce we can implement in Java, Python, C, C++, Shell script. It supports many languages. Currently, no one using MapReduce. So in the place of MapReduce, alternatively, most of the people are using Spark. Spark we can implement using Java, Scala, Python. Alternative to MapReduce, processing framework we are using Spark. But storage we are still using Hadoop only. Hadoop architecture Hadoop architecture is implemented based on master slave architecture. Master slave architecture. Master slave architecture. So what is master slave architecture? So master slave architecture, one mission acts as master and multiple missions acts as slave missions. So this is master mission, and these are slaves missions. So master always receives requests and assigns tasks to different slave missions. So master responsibility is taking request from different clients, and assigning task to different slave missions. So this is the responsibility of master missions. So here, if you observe this architecture, if master mission fails, what will happen? So there is no possibility to accept any request, right? So to resolve this problem, in existed architecture, we have one more master, called secondary master. So this is called primary master, primary master, and we also call this is active master, and this is secondary master. So this is also called passive master. So we also call this is backup of active master. So if active master goes down, passive master become active master. If active master goes down, passive master become active master, then it will take request from clients. If active master goes down, passive passive master become active master and takes request. Okay, so this is existed master slave architecture. Coming to Hadoop master slave architecture, Hadoop also has master daemons and slave daemons. Slaves we can take n number. There is no limit. Slaves we can take n number of missions. So there is no limit in our Hadoop architecture. Hadoop architecture. Generic master slave architecture. Yeah. Hadoop master slave architecture. So in this Hadoop master slave architecture, job tracker or resource manager, name node, secondary name node, and these are data node and task tracker or node manager. JT means job tracker, RM means resource manager, NN means name node, SNN means secondary name node, DN means data node, TT means task tracker. Next one, NM means node manager. Node manager. Yep. Some important notes. It is always always recommended to run data node and task tracker. Task tracker or node manager slash means R operation. So data node and task tracker on same machine. On same machine. We will see one by one why it is recommended to run both in same machine. Okay. One more important note. Secondary name node is not backup of name node. Name node like existed architecture. Like existed architecture. So existed architecture we see one active node and one passive node, right? But here secondary name node is not passive node. The secondary name node purpose is different. Secondary name node purpose is check pointing. We will see what is check pointing later. So check pointing purpose. So this is not backup of name node. So until Hadoop 1 architecture, until Hadoop 1.x version, until Hadoop 1.x version, Hadoop is single point of failure. Hadoop is single point of failure. Single point of failure. We call it as SPOF. Single point of failure. If name node fails, we have to wait until name node become up. Okay. So if name node fails, we have to wait until name node become up. So that's why we are calling Hadoop is single point of failure until Hadoop 1.x. Okay, in Hadoop 2.x, so third node, important node, third node, from Hadoop 2.x, Hadoop 2.x, Apache introduced high availability, high availability called HA. We can take multiple name nodes, multiple name nodes. So one name node we can make it as active, another name node we can make it as passive. So in Hadoop 2.x version, they introduced this feature, high availability feature. Okay. So before 2.x, it is single point of failure. Single point of failure. Again, this Hadoop architecture divided into two. One is HDFS architecture, HDFS architecture, and another one is MapReduce architecture. MapReduce architecture. So in HDFS architecture, two masters. One is name node and another one is secondary name node. And you can take n number of data nodes. N number of data nodes. In HDFS architecture, we have name node and secondary name node are masters and data nodes are slave machines. So here name node is a master machine. It will take client requests. So HDFS master slave architecture, HDFS master slave architecture is responsible for storing data. HDFS master slave architecture is responsible for storing data. Coming to MapReduce architecture, in MapReduce we have name node, job tracker or resource manager, and multiple task trackers or resource manager, node managers. So master machine is job tracker or resource manager, job tracker or resource manager, task tracker or node manager. These master receives processing requests. So this master receives storage requests. Storage requests. So MapReduce master slave architecture. MapReduce master slave architecture is responsible for processing. Yep, we'll see this one. Kalai Rasan, right? Yep. So we'll see this one how failures are handled. Okay. So HDFS architecture always takes storage request, and MapReduce architecture always takes processing requests. So if you write any MapReduce applications are big or high. Any processing is performed by job tracker and task tracker or resource manager and node manager. Okay. So this is HDFS architecture and this is MapReduce architecture. So these are 5 different daemons. Let's first see HDFS file system. HDFS. HDFS stands for Hadoop Distributed File System. Hadoop Distributed File System. First, what is file system? What is file system? General meaning. Collection of files. Pardon? File system simply a storage. Storage. So file system means it's a storage. Is a storage in operating system. File system is a storage in operating system. Whether you use database, whether you use anything, finally storage is in file system only. Okay. Yep. Yep. It's to file system is presented in hard disk. Hard disk. So our data is going to store in hard disk. So file system is a storage in operating system. Operating system, file system, operating system, file system splits into blocks. Splits into blocks. Splits into blocks. For example, this is our hard disk. In this hard disk, assume if you store just 1 MB file, 1 MB file, 1 MB file. Assume this is our hard disk. So this one splits into multiple blocks. This one splits into multiple blocks. Each block size is 4 KB in old operating systems, 8 KB in new operating systems. New operating systems. So block size of this file is 4 KB. This block size is 4 KB or 8 KB. If it is old operating system, it is 4 KB, and it is new operating system, block size is 8 KB. So because of this 4 KB, 8 KB, at a time it will read 4 KB, 4 KB data. Writing also it will write 4 KB, 4 KB kind of 4 KB, 4 KB data. So if data size is high, it will take more time to write. If data size is high, it will take more time to read data. At a time it will read 4 KB or 8 KB. So reading is little slow. Writing also little slow. If you observe, I already told HDFS file system block size is 64 MB in Hadoop 1.x, right? In Hadoop 1.x, 128 MB from 2.x, from 2.x. So it is 128 MB. Block size is same block size is 128 MB. Where is 4 KB? Where is 128 MB? So reading and writing speed is very faster in Hadoop file system. How we can achieve 128 MB? How we can achieve 64 MB? Finally, whether you are using Hadoop or whether you are using database, finally everything stores in operating system only. So database, how database block size, how database block size, simply instead of how, database block size, database block size depends on operating system, operating system. That's why, so database block size also 4 KB or 8 KB. Internally, we are thinking we are storing in tables, right? We are thinking we are storing in tables. Tables backend is file system only. Tables internal storage is file system. Okay. So internally, tables stores in 4 KB or 8 KB blocks. Okay. Yep. Let's wait. I'll explain. One more important point about this operating system file system. Operating system, operating system, file system, operating system file system starts as part of part of operating system process. Operating system, operating system process. So we cannot increase, we cannot increase or we cannot decrease, we cannot decrease operating system file system size. Operating system file system size. So coming to HDFS, HDFS file system, HDFS file system is a user space file system. User space file system. It runs after after operating system started. After operating system started. So Hadoop started after operating system started. That's why it is user space file system. It runs not as part of operating system process. After operating system started, HDFS file system runs. That's why we can customize HDFS file system size. We can customize HDFS file system size. That is, first, Hadoop HDFS file system block size. HDFS file system block size is 64 MB until Hadoop 1.x, Hadoop 1.x 128 MB from Hadoop 2.x versions, 2.x version, but it is configurable, means changeable. It is configurable means changeable. We can increase or decrease block size. We can increase, decrease HDFS file system block size. It is highly recommended, highly recommended to increase or decrease as multiples of 64 MB. For example, default is 128 MB, right? You can increase 64. You can increase 64 like this. It is recommended. Okay, it is recommended. In Hadoop installation path, in Hadoop installation path, like Hadoop underscore home slash etc slash Hadoop slash conf. There is a file called hdfs-site.xml. In this file, we define block size. If we not specify, if we not specify, it will consider default block size. If we not specify, it will consider default block size. So we know default block size, right? 64 MB. Okay. In Hadoop installation path, there is one XML file. In this XML file, if you want increase or decrease, we define that size. Okay. If you not define any size, it will consider default block size. That is 1.x. So latest versions 128 MB. 128 MB. Yep. So if you want to increase, it is recommended to increase in this way. We can also increase 128 MB plus 10 MB, but while processing it is difficult. So that's why it is recommended 64, 64, 64. Yep. Okay. So what is block? What is block? So block is a small piece or chunk of data. Chunk of data. Block is a small piece or chunk of data. Tomorrow class we'll see how data stores in HDFS file system. So we saw HDFS architecture, right? we saw HDFS architecture, right? When user places file into HDFS architecture, what is happen with the name node, and what is the role of name node, and what is the role of data node? We'll see this process in tomorrow class. Okay, and this Hadoop course is complete free. So for free training, we are not recording, we are not recording, and we are not providing videos. We are not providing any videos. It is recommended to write notes parallelly with the class. Okay, and the HDFS part, we are going to discuss practicals, HDFS practicals. After practicals, we start briefly MapReduce, then we start briefly Pig, then we discuss in depth about Hive, and in depth about Scoop. Okay, so tomorrow class we discuss this one, how do we place HDFS file system into Hadoop architecture, and what is the roles of name node, and what is the role of data node, how data is going to store into HDFS file system. Then tomorrow we'll discuss how Hadoop achieves fault tolerance, fault tolerance, fault tolerance. And tomorrow we see some important features of Hadoop. Okay, that's it for today. Do you have any queries in today's class? Yep, one of our student question is, when will we do installation in practical life? So as a Hadoop developer, we cannot do any installation part. So Hadoop cluster is created by Hadoop administrators or DevOps engineers. So as part of our practical part, we install a Hadoop single node mission, single node, single node mission. Then we do our development in single node mission, but in real application development, sorry. So we see this kind of architecture. So cluster architecture. So we have multiple master missions, we have multiple slave missions, we have multiple master missions and multiple slave missions. Let me give you clear clarity. So we have master slave architecture. In this we have multiple missions, multiple missions. In these multiple missions, some missions act as client missions. Some missions act as client mission, client mission. So we access this client mission. Not all missions act as client mission. Some missions act as client mission. Then we connect to this mission. Assume this is our development mission, our mission. This mission we may have Windows operating system. Windows operating system. So in this Windows operating system, we install Putty software, and through Putty software, we connect to client mission. We connect to client mission. Whatever the commands we write, we type here, right? Hadoop HDFS commands. HDFS commands. We type HDFS commands in Putty console, but these commands are going to execute in this mission. So this mission access this entire cluster. This mission access this entire cluster. Okay, so this entire cluster setup and managed by Hadoop administrators. As a developer, we write our MapReduce applications, Pig applications, Hive applications, Scoop applications. Then we submit hdfs commands or any program to client mission. Client mission submits our program to cluster. Okay, as a developer, so we don't have a separate mission, right? Separate setup. So what we are going to do in our Windows mission, Windows mission, Windows mission, we install any virtualization software. It may be VMware, it may be VMware, it may be VirtualBox, or any other virtualization software, any other virtualization software. In this virtualization software, we install Linux, and we install Java, and we install Hadoop. So we install all these three components. If it is a Apache Hadoop, we do these all these three things manually. If it is a Apache Hadoop, we do all these three manually. If it is any other vendor, we have different vendors, right? So we have vendors like Cloudera, Hortonworks, Big Insights, HD Insights, right? So as part of our course, we see Cloudera installation. If you use Cloudera installation, Cloudera provides Linux, Java, Hadoop already installed. They give us virtual machine. We set up that virtual machine to in this virtual machine. They give us image, virtual machine image. We add that virtual image to our VMware software or VirtualBox software. Okay. So for Cloudera uh, setup, minimum 4 GB RAM is required. Sorry, minimum 4 GB RAM is required. If you have 8 GB or 16 GB, it is more add-on advantage. Yep, Cloudera provides all. Cloudera, Cloudera, sorry, Cloudera image contain image already installed, Linux, Java, Hadoop plus development tools. These all are already inbuilt. We just attach this image to our virtual machine software. Okay. So as part of our development, we install this Cloudera image. Yep. In Hadoop architecture, I said I said it is recommended to run data node task tracker in slave missions, but recommended to run job tracker in separate mission, name node in separate mission, secondary name node in separate mission. But in our single mission, all daemons runs in a single mission. In VirtualBox, we attach Cloudera image. So because most of the time we have a Windows missions, so to share our Windows mission, our hardware, we are installing virtual missions. So any virtual mission softwares, virtual mission softwares saves resources like RAM, hard disk, LAN card, etc., CPU, etc. All these are shared by virtual machine to our new operating system. Okay, we can run both Windows and other operating systems parallelly through this virtual machine softwares. Okay, I will show you how to download this VMware software, and I will show you how to download Cloudera software. Okay, so that's it for today, and we will meet tomorrow and we'll discuss some more important points of HDFS file system. Okay, yeah.